Welcome to the channel Data Science Demonstrated. In this video, I will show you a technique called micro-outlier removal. Now this technique will help you make massive climb with minimum effort in the Kaggle's data science competitions. I will show you on how I've used it to go from a bottom 10% to top 30% in the Titanic Survival Prediction Challenge. So friends, let's get started. But before that, do not forget to subscribe to the channel, like and comment on the video. You can also visit my website experienceddatascience.com where you will be able to make all analytics on your data with zero coding. Let me first start with the results I've got using the micro-outlier removal technique on the Titanic competition leaderboard. Now without this technique, my rank was around 12,000 out of about 14,000 participants. But after applying this technique, my rank jumped to close to 4,000, putting me in the top 30% of the leaderboard. And I did it with minimum effort. I did not use feature engineering. I did not fill up any missing values. I only used few columns and I did not use any complicated machine learning algorithms. I just used plain simple decision tree. The objective of this video is not to show you on how to develop the best accurate model, but on how to climb the leaderboard with minimum effort using the micro-outlier removal technique. Here is some background information about the model training on the Titanic data which I've used. To keep things simple, I've taken only few fields which are the passenger class, the sex, the sibling, the parent-child information, the fare and the embarkment port. The field age is not taken as it contains a lot of missing values. I also did not create new fields with feature engineering. And the machine learning algorithm which I've used is a basic 5-level decision tree with 70-30 train test split. Shown here is the decision surface based on the training dataset and the decision tree algorithm. The decision surface which predicts the survival is shown in green color, and the decision surface which predicts the non-survival is shown in red color. Now we can observe that the decision surface which predicts the survival is mostly located in the middle, and the decision surface which predicts the non-survival is located on the sides. Now each dot here represents a passenger in the training dataset. The blue color point are the passengers who did not survive, and the green color points are the passengers who survived. We can observe that the passengers which did not survive, which are shown here as blue points, are generally grouped together. And similarly, the passengers which survived, which is shown as green color points, are also grouped together. So a micro-outlier is a survivor within a cluster of non-survivors. So for example, a point which is shown on the screen. And similarly, a micro-outlier is also a non-survivor within a cluster of survivors. So for example, a point which is shown on the screen. Now let us analyze the micro-outliers which are situated at the top left. Now when I hover over the passengers in this cluster, I see a radar plot for each point. Now you'll observe that all the points are related to passengers who are male, who have a high passenger class, which means the third class, and those who have embarked from the port S. Now all these passengers did not survive except the micro-outlier point. Now this specific micro-outlier point corresponds to the passenger by the name of Patrick Eugene Daly. You can read about how he survived in the link which is shown on the screen. Now he was a third class passenger located in the lower decks where the water had hit first. He had jumped into the cold water. He had no chance of surviving. However, he claimed that the thickness of his overcoat attributed to his survival, a garment which he held for many years, and he named it as his lucky coat. So though we are happy for him that he survived, but he is not good for machine learning. Now people who luckily survived due to some vague reasons such as thickness of the overcoat are outliers which messes up the machine learning model. So the best thing to do is to remove the data from the training set. So the micro-outlier technique identifies such lucky persons automatically in the Titanic data. And you will not be able to do this with any classic outlier detection algorithms. So I've removed the 6 micro-outliers which are shown on the screen. I retrained the model and resubmitted my results. And this gave me a big climb in the leaderboard compared to the submission without using this technique. So micro-outlier removal is a good intuition-based visual approach to improve your machine learning model accuracy without doing a lot of complex coding. In a way, we are removing data points that are unnecessarily complicating the model, and thus we gain in overall model accuracy. So my friends, hope you have enjoyed the video. Let me know in the comments below how would you use the micro-outlier technique. Do not forget to subscribe to the channel as well as like the video.